In this video, we will look at the other trigonometric functions: tangent, cotangent, secant, and cosecant. Now, if you notice, tangent has vertical asymptotes at negative pi over 2 and pi over 2. And that's because tangent is defined to be sine over cosine. So wherever cosine is 0, 1 over 0 would be undefined. And cotangent is defined to be cosine over sine, so the asymptotes for cotangent will be at pi plus or minus pi k. And the asymptotes for tangent are pi over 2 plus or minus pi k. Okay, there's a graph of the cotangent. Secant and cosecant functions, what we will do is we will draw the corresponding sine or cosine, and then we will flip the graphs. So the first one is secant, and the reciprocal function of secant is cosine. So wherever cosine is 0, which is at your 90 degrees or pi over 2, notice their vertical asymptotes are negative pi over 2, pi over 2. And so they are found at pi over 2 plus or minus pi k. Here's a picture of the cosecant. Cosecant is the reciprocal of sine. So wherever sine is 0, which is 0, pi, 2 pi, we will have vertical asymptotes. So again, what we're going to do is our tangent and cotangent, we'll graph those. But to graph sine, cosecant, we'll graph sine and then do the reciprocal. To graph secant, we'll graph cosine and do the reciprocal. So we know that y is equal to 2 tangent of x. Now, tangent, secant, cotangent, and cosecant do not have any amplitudes. The 2 is just going to stretch it. So I know for tangent, because tangent is sine over cosine, I'm going to have an undefined value or a vertical asymptote where cosine is 0. And cosine of x is equal to 0 at pi over 2 and negative pi over 2. Okay, the period for tangent is pi. So when we graph it, what we have is at negative pi over 2, we have asymptotes. Okay, because sine of 0 is 0, you go through 0, 0. Halfway is 45, and this is where at the 45 degrees, or in this case, negative pi over 4 and pi over 4, it should be 1. However, but because of the 2, it's multiplied it. So what happens is you go down 2 and up 2. Because tangent is an increasing function. It looks like this. Kind of a rough sketch. Make sure you do not cross those asymptotes, but approach the asymptotes. Okay, y equals cotangent of 3x. Notice where the 3 is here. This time it's not going to stretch it. What it's going to do is it affects the period. So the period of cotangent is pi. So the period for this graph is pi divided by b. And in this case, our b value is 3. So the period is equal to pi over 3. Now cotangent is a little bit different from tangent. It will be shifted, different asymptotes. So what you have is cotangent is defined to be cosine over sine. So we have an issue where the denominator is equal to 0. And that's at 0. So when we graph this, our asymptotes will be at 0. And in this case, pi over 3, which is your period. So I'm going to go ahead and put my asymptotes in. And we will label that. Okay, so this value here would be pi over 3. Okay, halfway it would be at 0. And remember, cotangent is a decreasing function. So when I go to graph that, just kind of a rough sketch, it's going to go down and curve like that. And I could graph halfway, which will give you your amplitude, not amplitude, but the multiplier of 1. Okay, so that would be your cotangent. Okay, here the reciprocal of cosecant is sine. So we're going to actually graph a sine. So this is going to go up 2. My amplitude here is 3. My period is 2 pi, because it's 2 pi, divided by 1/2, which is 4 pi. My count is going to be pi. So when I go to graph this, I'm going to go up 2. And there's no right or left shift. And I'm going to graph sine. So my period is 4 pi. My amplitude is 3. Let me go ahead and count up 3 here. And remember, it counts not from the x-axis itself, but from the shifted x-axis to make our math a little bit easier. Okay, so I'm going to go 1 pi, 2 pi, 3 pi, and 4 pi. Okay, sine always starts at 0, so I'm going to graph 0, then it goes up. But instead of going to 1, since the amplitude is 3, I'm going to count here, 3. 1, 2, 3. So 3, then back to 0. Then from here, down 3. 1, 2, 3. And then back to 0. So, now remember, this is the sine graph. It would look like this. Notice your period is 4 pi minus 0. I'm looking at the x values, which is 4 pi, and that confirms it. But what we're asked to graph is the cosecant, which is the reciprocal. So we're going to flip this. So we would have undefined or vertical asymptotes where the sine graph is 0. And if we flip this, we are going to have U-shapes like this. And that would be cosecant of 1/2 x times the 3 in front plus 2. So the purple are the graph values that you want. The asymptotes here, you want to show your vertical asymptotes. And then the cosecant has U-shaped graphs. And so does the secant. All right, so let's graph the secant here. Now, to make our math easier, we're going to go ahead and factor out that 2. So you have y is equal to -3 secant 2 x minus pi over 6. So that when I distribute it back, 2 times x is 2x, and 2 pi over 6 is equivalent to pi over 3. Okay, secant, the reciprocal is cosine, so I would like to graph cosine. So the amplitude is equal to the absolute value of -3, which is 3. The period, now we're back to cosine, so it's going to be 2 pi over 2, which is pi. You're going to shift right pi over 6. Notice there's no up or down shift. And our count is going to be pi over 4. So what does that look like? So when I go to graph this, I'm going to shift to the right. This is pi over 6. And I'm going to add pi over 4 to get these next 4 x values. So if I do 1/6 plus 1/4, and then we'll add a pi, we get 5 pi over 12. And this is just pi here. Okay, so I'm adding, the count is pi over 4, which is 3 pi over 12. And pi over 6 was 2 pi over 12. That's why we did 2 plus 3 is 5. Now 5 plus 3 is 8 pi over 12. Please notice again, I am not simplifying. 8 plus 3 is 11 pi over 12. 11 plus 3 is 14 pi over 12. And we can come back and we can simplify all of these fractions. Okay, our amplitude is 3. So let's go ahead and let's space it a little bit here. All right, so we want to graph cosine, and then we will do the reciprocal. Cosine normally starts at 1, but because it's a -3, it's going to go down to -3, then to 0, then up to 3, then back to 0, then down to 3. So that your graph looks like this. Okay. So what we have is cosine, but that's not what we're asked to graph. We are asked to graph the secant, which is the reciprocal. So where cosine is 0, if I will put asymptotes, and I will flip it. So I need to erase the count. My count got a little bit into the picture here, so let me erase that. And my shift. I'll go ahead and I will write those above here when we finish. All right, so what has to happen here is, see, this is approaching 0. Well, 1 over 0 would be infinity, so it's going to approach negative infinity. Here, it flips like this and makes U's, and then this piece gives you this part of the graph. So the purple with the asymptotes would be the graph that we want. The count is pi over 4. And let's see, I did not say this, but we're going to shift pi over 6 to the right. And that is honestly the easiest way to go ahead and graph these functions, the secant and the cosecant, is to go ahead and graph the sine or cosine first. So have fun on your trig